In today's discussion, we will focus on a particular topic named classification technique, and we will learn a tool named decision tree, and we will see that how decision tree is able to classify the objects, or rather classify the items or data items, whatever you say, how this tool is or how this technique is helpful to us. We will just see. Okay, so before entering into the concept of decision tree, we will learn what is a supervised and what is an unsupervised learning, right? So supervised learning is mainly based on for classification problems, and unsupervised will is for clustering problems. Fine. So let us say we are having some groups, or say we are having some labels, right? And we know that for the training data, for a particular data with which label it is associated to, right? Now based on that, say data 1 is associated to label 1, data 2 is associated to label 2, in this fashion. Now based on that labeling, we can build up a model, and whenever a new data set will come to the scenario, we have to fit that data, not data set. If a new data enters into my model, we have to map that data correctly, right? So we have to generate the output correctly for that data. And here this labeling is available. That means for whenever we are working on the known data set, that is whenever we are working with the training data set, we know for a particular input what will be the output, and based on that we build the model. Okay, but if the case is unsupervised learning, here you will be having only input set, no output set will be available. Now how to train the model, or how to build the model? So whatever we are going to do, we will just study whatever the data set is there. Okay, we will get some measurements, we will get some observations, and with the help of that we will try to build the model. Okay, means but just by observing what the nature of each data is, we have to cluster them to different groups, and we have to build the model accordingly. So if we have to specify in one sentence, for supervised learning we will have the set of both input and output for my training data set, and using that input and output mapping, we are going to build up a model. And whenever we will market my model, my new an unknown data will come, and we have to label it properly, right? And in case of unsupervised learning, there will be no output set, only input set is there, and based on the characteristics of the input set, based on the observations on the input set, we are going to frame the model. Fine. Now if we have to see this classification problem, and remember one thing, in this module we are going to concentrate on classification problems only. Okay, in this class we are going to learn only one technique, that is decision tree, and in the later classes we are going to learn different kinds of classification problems. Okay, different kinds of tools or techniques available, which we can using those tools we can solve these classification problems. Fine. And in the later module we are going to learn clusterings as well, but for now we are going to focus on this classification problem. Here this classification problem is going to predict categorical class label. Now see one thing, it works on both discrete or nominal data, right? Discrete data means what? It is not going to consist of, it is not a real number problem. Okay, it will have discrete values. If you want to know more about discrete or nominal values, we have covered that in module 1, you may revisit it. Okay, now it is going to classify the data, or it will construct a model based on that input output mapping what I was talking of, and using that data set, means using the training data set, it has built a model, and for new data which has arrived into the scenario, it is going to work accordingly, right? We have developed the algorithm, using the input and output pair what we are having. And now for new data, it is not having output with it, but by feeding into that model we are going to predict its output. That is our goal here. Fine. So here numeric prediction, like models will have continuous valued functions, and it can predict unknown or missing values. Okay, now see some typical examples. Here we can apply some classification model, say credit or loan approval, right? Say we are having different range of income. Say if someone is getting a salary of monthly salary of say 30,000 to 40,000, so how much loan we are going to sanction for him. If the leveling is say 41,000 to 50,000, how much loan we can give to that person. Okay, and then the medical diagnosis, right? So here you can see just it is by just seeing the structure of the tumor, we can extract different features, that what is the what is the radius of that, or what is the diameter of the tumor, whether what is the shape of that tumor, right? So based on this kind of features, there may be many features, many more features. Any medical expert will be able to guide us in this domain, right? So how to determine whether a tumor is cancerous or benign? Using those features we can just build a model that if this feature holds, if this feature holds, and if this set of feature holds, then we can say that this tumor is cancerous or else benign. So you can just see that it is having firstly it is having all those data. For those we know, for this kind of features we have to classify this tumor as cancerous, and for this as benign. Okay, now whenever a new data will come for whose output we do not know, so what we are going to do, we have to feed the features to my machine. So wherever the features are going to get satisfied, it will be mapped to that section only. Okay, it is helpful in fraud detection as well, or other there are many other areas of applications. Now see, this classification problem is a two-step process. First begins with model construction, and second with model usage. So these are the two steps we were talking of now. First, construction means what we were talking of. We are having training data set with us. We know for this input we are going to generate this output, and using this labeling, this class labeling, or this input output mapping, we can construct a model. Right now, whenever we have to test the accuracy of my model, say we are having some input and output pair, and we have developed an algorithm using that input and output pair. Now we have to justify whether my model is accurate or not, or rather what is the level of the accuracy of my model, means for how many new data it can map correctly, and for how many data it cannot map correctly, right? So if the chances of failure is more, we have to refine our model, we have to rebuild it, or we have to modify it rather, right? So see here, so model usage means it is going to estimate the accuracy, and using accuracy means how we are going to test it, using the test data. If we are having a new data, and how means here for that data we know the output actually, but we are not going to feed that output to my machine. So whenever I will feed my new data to the machine, it will generate an output, and we have to tally that output with the original output, so we can get the accuracy then. Fine. So these are the two steps a classification problem uses. You can see here, this is the first step, model construction. Just see here the total table means it is the training data. You can see here it is having three different attributes, namely name, rank, and years. Okay, now here we are, based on these three criteria, we are going to return either yes or no. There is so two labels are there, one is yes, another is no. Now see, these are the data set I have. We know that if name here rank is say professor, and here what is, or if the rank is professor or years is greater than 6, right, then only yes is coming. You can see here, if we tally this data, that for Mike the rank is assistant professor, right? And years is 3, so it is returning no. Next, for Mary the rank is assistant professor and years is 7, so one of the criteria is satisfying, right? So this model means this, if rank is equals to professor or years is greater than 6, this was not predefined. Rather using this data set, this table, this training data, we have developed the model, right? So using the data, just you can see here, but just by studying the data, we are having both input and output. For this case, this first 3 columns is the input set, and the last one is the output set. So using this input output pair, we have developed the algorithm. So we have constructed the model, right? Now the second process is doing what? We have to test it, right? Just see here, these are the test data. Name is Tom, rank is assistant professor, and year is 2. So here rank is assistant professor, years is 2. So it is not satisfying any one of the property of my, or any one of the condition whatever the model I have designed. So it is returning no. Just you can see here, it is classifying correctly. Fine. Now see, for George the rank is professor and years is 5. So either it has to be, he or she has to be professor, years of engagement has to be more than 6, right? So it is satisfying the rank category. Now it is returning yes. So my model is working fine, right? So the previously we have trained my machine and we have developed the algorithm using the training data. Now the model whatever I have developed, we are using it for the unseen data or the test data. Fine. Now we will move to our topic here, how decision tree can help us in classifying the problems. Okay, so here you can see one more thing, that there will be many more attributes present, right? And you can see there in the previous example there was the designation, that is the rank, and the years. So there were only 2 attributes or 2 dimensions of data. Say we are having 10 dimension of data, means to define a data we are using 10 different features. Now decision tree will help us that which feature among all is the most important feature. Means if we begin with that feature, we can come up to the decision more quickly, right? So which feature to extract, which means we will rank the features here, right? So firstly, which feature we are going to extract from all the available features, then using which feature, after using the first feature, we will say after using the first feature we will get some data set, right? And again we will extract the second feature and we will try to use that second feature among this minimized data set. Okay, so using that we can predict the decision. So rather I will explain the total decision tree using this famous example of playing tennis. Okay, this is a famous example. You can see here this decision tree, we are having a data set, right? And using different criteria, that is outlook, humidity, wind and temperature, we are going to decide whether we are going to play tennis today or not. Now our motive or our target is to extract the most important feature, that is whether we will first decide based on outlook or humidity or wind or temperature, means which feature is the most important and which feature is least important. This my decision tree will decide that one. Okay, so here you will see after the construction of the whole decision tree, I will tell you the details of decision tree, but just look at the diagram. here we have used outlook, we have used humidity, just see the yellow color boxes, and we used the wind. We are not using temperature at all. So you can see, if you learn how to construct this decision tree, then you can understand that temperature is not an essential feature at all. So you can see, out of these 4 features we have already discarded one, right? So here what it is doing, it is ultimately reducing my dimension, means which feature we are going to study on taking the decision. Okay, so let us just move to the concept of how we are going to take the decision. Let's see, this is my total training data set. Okay, there are 14 data given to us. Outlook is my first feature, or first input vector, you can say. Then temperature, then humidity and wind, and my decision is whether I'm going to play tennis or not. You can see here, for the sake of simplicity, or to make it highlighted, I have marked the yes, means whenever my decision is yes, I'm going to play tennis. Okay, that I have marked those row with red color, and rest I have left. Okay, so here outlook, you can see here, if we revisit my previous slide, you can see here outlook can be of 3 types. It can be sunny, it can be overcast, it can be rain. Humidity can be of 2 types, high and normal. Wind can be of 2 types, strong and weak, right? So these are the input values, different input values. Similarly, temperature can have 3 values, that is hot, mild and cool. Fine. Now let us move that how we are going to take this decision. So whenever we have constructed the decision tree, that is, we are going to learn from the next slide, right? So if this is the total decision tree, you can see here, whenever we are going to take the decision, and if we have to represent it in this form, in mathematical form, it is like, just focus on the yes part, just start from the root. If outlook is equals to sunny and humidity is equals to normal, then it is yes. So see the first line, outlook equals to sunny and humidity equals to normal. Next is overcast. If outlook is equals to overcast, then it is yes. Okay, then if outlook equals to rain and wind is equals to weak, then it is yes. So we are writing this in the form of conjunctions, or disjunctions of conjunctions rather, right? So ending is there inside the bracket, and they have been marched using or, that's why disjunctions of conjunctions, right? So in this fashion we are going to represent the decision tree, but we have to learn how to build this decision tree first. Okay, so this is the how we can search for a good tree. Okay, so if you have to think of building a decision tree, the space of decision tree is too big. Okay, this is one drawback of decision tree, because it consumes space complexity is large. But before going to the disadvantage of this, we have to see what are the advantages of it. Okay, when we have to stop and when we have to choose it and when we have to split it, we are going to learn from the example only. This is the algorithm, you can just go through it. This is a famous called ID3. Okay, ID3 algorithm, and this is the formal step-by-step procedure, and these are the criteria that when we have to stop and when we have to split. Okay, before that we have to learn 2 more features, that what is entropy and what is information gain. Okay, let us see. One node is there named A1, and it has total 29 positive values and 35 negative values. Okay, again, whenever this A1 is true, for this true condition, it has 21 positive values and 5 negative values, and when it is false, it is like so. So if for A1, this we have just split it into 2 branches, and it is like this. Okay, now see here that if you just go from bottom up approach, for true case it has 21 positive and false case it has 8 positive. So 21 plus 8 is 29. That's why for A1 total 29 positive values are there. Again see, for true it is having 5 negative values, and for false it is having 30 negative values. So the negative value for A1 is 35. Similarly for A2. Okay, now we have to see that how to calculate the entropy and information gain of this particular node, and why we need the entropy. We have to learn it before learning the how to calculate the entropy. Okay. Now here, whenever I told you that which attribute we are going to select, right? So whenever we have seen that example of playing tennis, so which attribute we are going to choose out of outlook, out of temperature, out of wind and all, which attribute we are going to select. So here we have to test that attribute at each node, that which is containing most useful, or rather which is proving itself to be most useful for classification, right? Means whose value is most, or rather the attribute which is most valuable in generating my decision. So how we are going to find out which attribute is the most valuable one? For that we have to find out the information gain. Okay, this is a mathematical concept and it helps in, it's a proven concept, and it's help in finding out that how useful a particular attribute is from all other attributes. And here we are going to learn how to calculate the information gain of a particular attribute. To learn the concept of information gain, we have to learn entropy first, because after calculating the entropy of a particular node, we can calculate the information gain of that. Okay, so here you can see, we know that entropy can be said as it's a measurement of uncertainty, it's the measure of purity, or it's the measurement of information content. Okay, just see how to find out the entropy. We have learnt in many various areas. We have learnt in chemistry that how to find the entropy, how to find the randomness of a particular thing. Okay, so here we are going to use this formula again. If you remember that one, this node, this one, that A1 is having 29 positive values and 35 negative values. Okay, so if we have to calculate the entropy of A1, just see that entropy of a particular node is the number of positive values, or probability of in a proportion, okay, or proportion or the probability of having positive values minus log base 2 that probability, plus the probability of negative, and minus log base 2 that probability of the negative one. So here just this is the graph. Okay, so here without sticking to this, if we have to calculate the entropy, just see here, do not consider our gain part, see the entropy one. Here A1 had 29 positive values, 35 negative values, just plug it off. So the chances of being positive, or the probability of being positive, is 29 divided by 29 plus 35, that is 29 divided by 64, and the formula was minus log base 2 P1. So we have just kept this negative sign before the beginning of the equation. So it will be somewhat like this, minus 29 by 64 log base 2, 29 by 64, and for the negative part as well. So it is coming to 0.99. Fine. Now we have to look at how to calculate the information gain. We have calculated the entropy of my original node, that is A1. Now we have to calculate the information gain. See, Here we have calculated the entropy of the previous one, that means the original node we have calculated. Now see that information gain, how we are going to find out information gain? Firstly, what we have to do, we have to find out the entropy of this true node and the entropy of this false node, right? Using the same formula. So what is the chances of positivity in true? That is 21, and negativity is 5. So using the same formula, minus 21 by 26 log base to 21 by 26 in this just by plugging these values to the formula, it will be 0.71, and for the false part it will be 0.74. Now just see the formula of gain, what it is saying. Here the entropy of my original node, that is my root node, it is being depicted with S, since we are calculating the information gain with respect to my original node, right, minus summation of all the values, means here for true and false, if there are more than two nodes, more than two children, so it will be added up. Okay, see here, and now the SV means for this one of the child node divided by original into entropy of the child node. Just see the example what it is doing. So entropy of the original node, that is entropy of S, minus 26 by 64, right? Why 26 by 64? See, for the true part, how many values are there total? 21 plus 5, that is 26, and the total data set of this A1 is 29 plus 35, that's why 26 by 64. Okay, multiplied by entropy of this particular branch, that is for this true branch we have calculated it, and for the negative or rather false branch, it will be, what is the number of data sets on which we are working on for this false part? It is 8 plus 30, that is 38, and original data set there are total 29 plus 35, that is 64 values. Okay, so this the entropy of this particular branch, right? So it will be 0.27. Similarly, for this another example is there, you can calculate it. So why we have learned this? Because we have to apply this one for my original example. Okay, just look at this. Humidity can have two different values, right? So if you do not remember, just look at the chart table where the total training set is there. So humidity can be high and humidity can be normal. Okay, so these are the two choices of humidity are there. Now whenever you will learn this, just keep the table open, because if I have plugged the table here, there I cannot build a tree. Okay, so I have not kept the table here. So whenever my humidity is high, chance of playing tennis is 3, not playing tennis is 4. When it is normal, chance of playing is 6 and not playing is 1. Clear? So firstly, remember this one, we had a total of how many data? We had a total of 14 data. Fine. So just revisit it once. Okay, see, there are total 14 data, and humidity can be high or it can be normal, right? Now see, for high case, it can be yes for 3 different choices, right? See the high marked in red, and for other it has to be no, and similarly for normal. So we have to keep this in mind. Let us go back there. Okay, so just see here, for high cases there were 3 yes and 4 no's, and for normal this one. Now in total, when humidity is high, chance of playing tennis is 3, and when humidity is normal, chance of playing tennis is 6. So 6 plus 3 is 9. That's why just see the node of for humidity, the total positivity is 9. Just see at the values of S. For S, positivity is 9, and similarly negative case is 5. Okay, how to calculate the entropy of this node? It will be minus 9 divided by 14 log base 2, 9 divided by 14, minus 5 divided by 14 log base 2, 5 divided by 14. So it will come up to 0.94. Okay, now again we have to calculate the entropy for this high value only. So it will be minus 3 by 7, because 3 plus 4 is 7, minus 3 by 7 log base 2 3 by 7, and minus 4 by 7 log base 2 4 by 7. Similarly, we can calculate it for normal as well. Now if we have to calculate the information gain of per humidity node, it will be like the original entropy, that is 0.94, minus, for high, the total number of data value is 3 plus 4 is 7, and original data value is 9 plus 5, that is 14. So 7 by 14 multiplied by entropy of this particular node, that is 0.985, minus this one. For normal, the total number of data values is 6 plus 1 is 7, and the original number of data is 14, right? So 7 by 14 multiplied by 0.592, right? So the information gain becomes 0.151. Similarly, for wind we can calculate it. Similarly, we will calculate it for outlook as well. Just see here, instead of 2 different choices, outlook has 3 different choices. Now just look at the information gain, and we have not shown for it for temperature. You can just try it of your own. So you can see here we have got the information gain for all 4 attributes, and you can see here, so outlook is having the highest information gain, right? So we have started building our tree from the outlook, because we want to keep that attribute at the root of the tree which is carrying most valuable information, or whose information gain is maximal, right? Okay, so using this outlook, you can see here, for outlook, just look at this diagram, it will be clear. Just see, whenever we are choosing outlook, and if outlook is sunny, the chances of playing tennis is 2 and not playing is 3. If it is overcast, the chances of playing is totally positive. See, there is no value for negative, means no answer. And for rain, 3 and 2. So whenever we are building my tree starting from outlook, and if it is overcast, we can come to the decision, yes, we are going to play tennis, because there is no chances of negativity. But whenever it is sunny, we can play tennis, means the value out of this 5, we can play tennis for 2 values, and for not playing tennis, there are 3 more data items. Similarly for rain, right? So what we have to do, we have to take other features, because we cannot take the decision at this level for all the choices, right? So if we consider the sunny, you may consider rain as well, but since we are traversing from left to right, I'm going to stick to sunny only. Now we have chosen outlook, right? Now which remains, which 3 more factor remains? One is humidity, other is temperature, and another is wind. These 3 factor remains. So which attribute to choose next? That means, just remember one thing, how we are going to filter the data at this location or at this position. If my outlook is sunny, then which attribute I am going to focus on? That means whenever we have to work in this one, we can consider only data D1, D2, D8, D9 and D11. Why? Because for this data items, outlook equals to sunny is satisfying. So whenever we are going to bring up next attribute here, we are going to take our decision based on this 5 dataset only. We are not going to look at other datasets because it will not satisfy my criteria that outlook will be sunny, right? So if you just tally these 5 tuples or 5 rows where outlook is sunny, that is D1 tuple, D2, D8, D9 and D11, these 5 rows, you can see there are 2 chances of playing tennis and 3 chances of not playing tennis. So we have to split based on that one. Okay, see here what we are going to do. Here my root node will become sunny. So if we have to take a choice of among this humidity, temperature and wind, so with respect to sunny we have to decide whose information gain is highest using the same kind of thing. So here we know what is the entropy of sunny is, because here we have seen in our example, just see the sunny is having entropy of 0.971, remember it. Okay, so this information the entropy of sunny is 0.971, and for this humidity you can use it because humidity is having what are the features? It can be high or it can be normal. So based on that, finding that for high, how many yes are there and how many no's are there, and for normal, how many yes are there and how many no's are there. So you can calculate the entropy of humidity at this condition only. Now after getting that values, we can find out the information gain of humidity with respect to outlook being sunny. So the entropy of sunny was this 0.971, and we had, for minimizing factor, we are just keeping 2 decimal parts, so we are reducing it to 0.97, and you can see here the chances of not playing is 3 and chances of playing is 2, and that's why this one. And if you have to calculate the entropy for this 2 part as well. Okay, so just plug those values, it will come up to 0.97. Similarly you can find it for temperature and wind. So here just see the gain of humidity is maximal, so just we have to plug it here. We are plugging off humidity here. Now whenever the humidity is high, just look at the data set that using this, you can see here that for high the entropy has come to 0, because you can see here minus 3 by 5 multiplied by 0 and minus 2 by 5 multiplied by 0. So for we have to reach the decision also, because whenever the entropy is 0, that means there is only one choice, there are no other choices, right? So here we have considered this one. Whenever the humidity is high, the answer is a definite no. Whenever the humidity is normal, the answer is a definite yes. Okay, so we have successfully made the left branch, and I have kept this as an homework for you. Just after rain, now you are left with other attributes, that temperature and wind, and why this wind, if you tally this, the information gain of wind with respect to rain and information gain of temperature with respect to rain, you will see that information gain of wind will be higher. That's why we have chosen wind here. Okay, now you can see that all the root node of my decision tree is either a yes or a no, right? So that's why you can see here, using this decision tree approach, we can take the decision, and we are not using one attribute at all, right? We have discarded the temperature totally. So this is a very important tool for classification algorithm. And if we have to just see visit this one in form of this algorithm, right? So you can just go through this. This is the formal definition. In the next class, we are going to stick to this example, one more example, using in the same manner as of playing tennis. And with this, what we are going to do, we are going to see other ways of calculating, means other than information gain, we will learn gain ratio, we will learn Gini index, right? So how they are useful, we are going to look at those features as well. Thank you for now.